Welcome everybody. Welcome to the Data Science Invited Talk series. I'm Sid Mehni. I'm the Director of User and Learning Experience for the IU Data Science program. Today it's an honor to present our guest speaker, Dr. Duru Ahanotu. Is that right? Okay.
Yep.
So Dr. Duru is a leader in the field of data science working in the Bay Area. He comes with an experience of more than 25 years. He is currently the Director of Corporate Measurement for Yahoo's Strategic Planning and Consumer Insights Group within marketing, where his team supports several analytics functions such as data mining, dashboard automation, tracking and monitoring performance metrics, and ad hoc data analysis. He's also a graduate of Stanford University and has experience doing analytical modeling, executing pricing strategies through price optimization, and implementing, developing, and selling enterprise software. He's also an active member of the Yahoo Black Network. He earned a bachelor's in mechanical engineering with honors from Stanford, and he also has a master's and a PhD in engineering and economic systems from Stanford University. Today he's going to give a talk on organizing around big data. So just a reminder, after the talk we're going to meet in the next room, 101, for a personal one-on-one session with Dr. Duru. So without further ado, I would please join me in welcoming Dr. Duru.
Thank you, Sid. Oh, the microphone, forgot to put on the microphone here. Let's see. Can you hear me? Okay. Okay, cool. All right, thank you so much, Sid, for inviting me here to talk to the students here. I always like to take these opportunities to get out of the corporate world and come to the academic world, just because it's a nice change of pace, and also I get to meet so many smart people, and you all are studying things that I wish I could come back to school and study. These kind of departments didn't exist when I was in grad school or undergrad, and I think this is a great innovative way to bring data science into one discipline. And I'm always fascinated to hear about the kinds of things that you're doing now. So again, I created this talk, Organizing for Big Data. Really the main concept here that I'm going to take you through is sort of how we think about data science and big data at Yahoo, particularly from a marketing perspective is where I come from, but we'll also talk about other work that researchers and engineers are doing at Yahoo. Sid gave a great introduction. This is pretty much my corporate and academic life on one slide. I grew up in Berkeley, California. My mom was from Alabama. My dad was from Nigeria. They met at UCLA. As Sid said, I got a bachelor's in mechanical engineering and an honors degree in a department called Values, Technology, Science, and Society. And the reason why I like to put this kind of stuff up here is just to give you kind of an idea where I come from. I'm not sort of a typical engineer. I really like to do a lot of writing. And the honors degree that I got was a opportunity for me to do a lot of writing. And I basically applied technology to the development of popular music in the U.S. Then I went on to do my PhD in a department called Engineering Economic Systems, which is now called Management, Science, and Engineering. It's a combination of EES, Industrial Engineering, and Operations Research. And the idea there is to bring basically concepts of mathematical modeling to everyday problems that we face. And back in the day anyway, we like to think that you could solve almost any problem in society with mathematical equations and algorithms. And that's kind of where we are now with big data and data science, is we think we can, if we collect enough data and apply enough horsepower, we can solve any problem that people throw at us. Here are the companies that I've worked for. Expert Edge was a company that was founded by my thesis advisor in grad school. This was back in the day when we were really enamored with expert systems. And the big application then was for doing medical diagnostics. This company and what we built was diagnostics for robotics and automobile manufacturers. So I was working a lot in Detroit. and then another component was doing diagnostic equipment for semiconductor companies. So the idea was a machine fails, and then the AI would then take you through a decision tree, basically, on how to solve the problem. So that was a really hard problem to solve, because you can imagine the kind of horsepower that we brought to it. We didn't even have multimedia. That was kind of a new concept back then. So after I graduated, I went to Analysis Group, which is a company that basically was a boutique management consulting company. There I got a lot of experience in business, but the main product that we built was PowerPoint slides. And after 3 years of doing that, I wanted to actually build things I could put my hands on. So a friend of mine from grad school, he had co-founded this company called Wrapped. That's where I did the pricing analysis. We were, again, a very novel thing at that time. We applied pricing algorithms for computing equipment to the internet space. And we're helping publishers price advertising that they put on the web. And one of our early clients for doing that was Yahoo, just coincidentally. I was also fortunate enough to be a co-author on a patent involving the methodology that we use to help companies do that pricing. Microsoft bought us out. I continued to work as an expert on the software system to help sell it to other clients. And then from there, I moved on to Yahoo, where I am today. I joined Yahoo in a group that was a technology platform group, and I came in and helped them to consolidate reporting. Basically, all the product and program managers were doing their own dashboards in Excel, and I came in and consolidated it all. And through several reorgs and shifting around and stuff, I finally found myself in marketing. I won't take you through that whole history, but I've been at Yahoo now for 6.5 years, almost as long as I was at Wrapped. So this is almost my longest professional stint. So that's me on one slide. And this is my group. There are really 4 teams, but sort of I call it 5 sub-teams of things that we do. So the first one up there is not as important for my current team right now, but business intelligence is where we come in and optimize for marketing the way they do reporting on different metrics. And we basically try to automate or basically make their Excel-based dashboards as efficient as possible, but we've almost gotten rid of almost every Excel-based dashboard and replaced it with things like Tableau and also some ingrown platforms. Data engineering is basically, I have a small team of data engineers who help to pull data from our data warehouses. That supports the marketing analysts who need that data to support their research and their efforts to market Yahoo's products. I have a data scientist who basically provides advanced modeling support for the marketing analysts. External measurement is basically a team that works with companies like Comscore that are third parties that measure traffic on publisher sites. So there's sort of a neutral third party, and it's the accepted currency out in the marketplace for how to measure how our websites are doing. And then finally, Network Insights. I have one guy who basically sits on top of a weekly process where we're reporting out the health of the network to our executive staff, and he's also responsible for doing some other advanced analysis within the group. So that's the team. And as I said, for the talk today, I basically break it out into 3 components. We may not get to much of the third. It depends upon how things are going, but I like to put it in there in case I have an opportunity to talk about it. But the main gist of this talk is to introduce you to sort of the way we think about applying big data in an industry environment. So we're going to take you through sort of the framework for how we think about that. Big data in practice at Yahoo. I'll show you what we do with big data in marketing in a very high-level form. Unfortunately, only certain things I can talk about. So the stuff that's publicly available are actually things that our research teams have been doing and publishing out onto our various platforms. So I can talk a little to those. And like I said, if we have time, I'm going to talk about some practical implications for big data and have things that you should be thinking about as a practitioner when you go out into industry applying these powerful techniques and technologies. So to start off with, a cartoon just to show you, I'm sure, a scenario that all of you experience in your everyday life. Someone at a social event asks you, what do you do for a living? Or maybe it's, what do you do in school? And you respond with something like, well, I'm working on a framework to allow construction of large-scale analytical queries on unstructured data. And of course, that person says, wow, I'm really intrigued by that. and you have to calm them down because they get overly excited about the topic. I'm sure this happens to you all the time, but it is an example of why frameworks are important to learn. You can impress all your friends. But on a more serious note, I like to put this slide up as well because back when I was coming up, when trying to sell pricing analytics software in industry, we would encounter people who've been doing pricing for years, for decades, and they just know pricing. And it was very hard to convince them that a computer, that an algorithm could be smarter and do things better than what they had been doing or improve upon that. And the more experience a person had or the lower the margins of the product we're dealing with, the harder it was to convince them that their gut is actually a suboptimal way of approaching what's essentially a pricing optimization problem. So what big data is doing now, what's just commonly accepted today, decades later, is that following your gut really is just not, it's not something that people appreciate anymore. It's not glamorous. It's not, you don't impress anybody by saying, well, I just have this gut instinct when we have all this data and all this technology available to do better. What big data is doing now is taking this sort of standard framework that I'm sure you're familiar with in some form or fashion and really empowering it with data, with methods, with technology to basically make this iteration really fast. And what is this? Well, typically when we're trying to make a decision, we're trying to improve something, we start with a set of goals. In a company environment, it may be a strategy, it may be a hypothesis, it may be targets. And we start at that point and we say, well, how can we affect this goal out in the marketplace? Well, let's do some experiments. So we collect data, we do some experiments. Maybe you're familiar with A/B testing. If we're fortunate enough to be able to create a controlled experiment, we'll have a control, we'll have a treatment group, and we collect data. From there, once we see the results of the data, we're going to decide what are the best results and then act upon them in the marketplace. So it might be a tweak on a product. Once we put it out there, we observe whether we get the results that we expected. And depending upon whether it's a desirable outcome, if the answer is yes, we go back and we might push our goals out further. So if our target was to improve profit 10% and we're successful, then we'll push it out to 15%. And we just continue to iterate. If the outcome was not desirable, then we might go back to the experimental phase and then run some additional experiments, do some additional tweaks to see if we can get to the original target and the original goal. But powering all of this now more effectively is big data and data science. It allows us to go through this with more evidence and in a much more powerful way and oftentimes in a much faster way than we ever could before. So how do we do this then in practice on an organizational sense? I like to think of this concept of an insights supply chain. It's something I just came up with a few years ago. So every time I'm at a talk, I like to promote this, and I'm still waiting for the hashtags and all that stuff to come out on Insights Supply Chain. It hasn't happened yet, but I'm hoping with more talking on this concept it will. But basically, from my standpoint in marketing, there are these three components that go into building insights, starting with the data miners who collect data from the data warehouses, supply it to the analysts who then analyze that data, organize it, and then the insights analyst, which is an unappreciated, a role that I didn't appreciate as much until I came to marketing. Those folks with those skills basically take the data and the findings and package it in such a way that they can evangelize throughout the company and convince leaders to actually act upon the results. And something I like to tell to my team all the time, and I tell this to engineers all the time, is it's great to have all these techniques and be really smart, have a big brain, but if you can't communicate your results effectively, you might as well not have done anything when you come into the corporate world, because it really takes a lot of understanding big pictures, being able to condense very complex concepts into nice bite-sized concepts so that executives can understand and really figure out how they need to push the company in the direction that you feel like it should go based upon your results. So this is embedded within that whole process I just showed on the previous slide, where all of us are working towards common goals. If the company is functioning correctly, we all have common goals that we're working towards. The data miners are supporting the data collection side of the experimentation. The analysts are taking that data and helping to make decisions and give direction on how to act. The insights analysts are also helping to act, and they're responsible for observing the actual results. So you have the machinery, the framework around that, and you have the people operating within that. This is a serial version. Yes, question.
For me, it seems the data analytics group and insight analytics group have some task in common.
Yes.
So, and I can't understand why do you have two teams for data analytics and insight analytics?
Yep, so I have a slide at the end of this that addresses that. So I think of these as separate roles, and like I said, before I came to marketing, I didn't really understand that insights analysis is its own sort of set of specialized skills, but definitely the kind of technology we have available now allows a lot of these roles to overlap. And actually, I'll just skip ahead a little bit. So for instance, in marketing, we have a lot of folks that are actually very strong in insights analytics and do some of their own data analytics. We have data analysts who also can do some of their own data mining, thanks to Hive, for instance, that makes structured query language much more freely available. It doesn't take someone who has a computer science degree anymore to query a massive database of unstructured or structured data. So we're in a place now where these roles, there is a lot of overlap. And I have a slide that addresses exactly that observation. Thank you. So I just want to go into these individual roles really quickly. And again, my focus is on how we do this in marketing at Yahoo. So the data engineers don't just pull data from a data warehouse. And in marketing, some of their underappreciated roles are some of these included here. So for instance, they have to monitor and maintain infrastructure. The systems folks and the hardware folks have an infrastructure that serves the whole company, but my data engineers have to build their own infrastructure to be able to access that data in a very efficient and speedy way. And it's an underappreciated role, but it's an extremely important one. Also important is that they have to stay on top of the changes in the environment. So we not only have technical changes that happen all the time, but in the company we have changes to our products where our products are the instrumentation that we use to track how the products are performing, that changes all the time too. So that results in changes in schemas and so forth. And the data engineers have to stay on top of all of that if they're going to effectively pull data from the data warehouses. They also have to advocate best practices for cultivating this data. So these are requirements that they send back upstream to the hardware folks on, look, our life is difficult because of X. If you could only organize things this way, we could get the data much faster. And then, of course, finally, the thing that people think about the most about the data engineers is that they do coding and they query. But there's a whole bunch of other activities that go behind their success. Then we have the data scientists who, again, take the data analysts that include data scientists, and they take this data, and they have a few roles as well. Not just querying the data that they're given, but they also have to transform the data into something that's understandable, and that's directly related to the goals that have been set for the group in doing the analysis. They have to understand and develop relationships. So just because they have a big bucket of data in front of them doesn't mean that the relationships are just obvious. They actually have to do some analysis to figure out what those important relationships are. And then finally, they compile and organize this data, again, shaped by the overall goals and objectives that we've set for this decision-making process. And then finally, we have the insights analysts who are what I consider like the really creative minds, the imaginative ones, the ones who can take the data, the product of the data analyst and see how this can transform the business, can see how the messaging needs to go out into the decision makers of the company and create the products that will improve results. So they imagine, they create, they have to package things, they have to present, they have to be able to speak and talk in front of groups and really put things out in a very convincing way. And then finally, even after they've done that, they have to make sure that things are implemented correctly, they have to drive the adoption of the new principles or practices, and they have to evangelize across the company. And at a company like Yahoo, at Yahoo, that's really large, that evangelization process can be the do or die moment for whatever the project is that's done this decision making. So this is really, these two right here really drive the decision making. All right. So to your point, What's great about today's world is that these roles don't have to be in specific people, right? We don't have to have silos. We don't have to have people who are completely 100% specialized in any one of these roles. So I just drew this quick Venn diagram to kind of show how these overlaps can be created. Way far on the left, the data engineers still pretty much have dominion over things like Hadoop and Spark. But in the middle, we have a lot of this overlap where we have Pig is still largely the domain of computer scientists and people who know how to code. Machine learning, same way. But like I said earlier, Hive, SQL, Excel, these are tools that data analysts can use to act sometimes a lot more like data engineers. R, SAS, to some extent Tableau, insights analysts can use to act like data analysts. And then PowerPoint, of course, and other kinds of presentation tools are becoming better and better and better at allowing more and more people to communicate effectively. Of course, I know that PowerPoint is a tool specifically that's open to debate, but you get the point, that there are presentation packages out there that help a lot of us communicate a lot better and more effectively and bring really the power of multimedia into play. So yes, indeed, it doesn't have to be specific people in each one of these roles, and it's the tools that really allow us to take on overlapping positions in the supply chain. All right. So just to give you an idea of one of those overlaps is like I said, was Hive. This graph shows you the beginning of Hive at Yahoo, the early growth. So this lightish purple line shows the number of grid jobs in the millions that we do on a monthly basis. So over here, this is March 13th. That's about 13 million grid jobs in a month. Growing all the way to, what is that, around 22 million as of April 14th. And then here in 2013 is when our engineers started rolling out Hive onto our Hadoop platform. And it really took off towards the end of the year where we really had this initiatives like analysts need to be able to pull their own data. And this takeoff, I mean, it's kind of exaggerated. I mean, it's 2.5% of all grid jobs by April 14, but when you're talking about 20 million grid jobs, that's a pretty big deal in terms of absolute sense. As of today, or August 2016, we're now running about 32 million grid jobs per month, and I'm talking about over the entire company, not just in marketing. That would be kind of crazy if we were doing that kind of work all by ourselves. And Hive is now about 6 to 7% of those jobs. So it's a really big takeoff at the company in terms of the empowerment that analysts now have to pull their own data, to analyze data right from the source. And Hive overall is about 13% of all computing power. It takes up, all the 13% of computing consumption on Hadoop currently at Yahoo. All right, so just as a quick summary, I basically showed you how big data supports decision making through frameworks that we're all very familiar with and empowering them, making them faster, more effective. I introduced this concept of an insight supply chain that shows how the role of people in this whole decision-making framework using big data. And then the last slide, of course, gave you an example of how these tools are allowing people overlapping roles. Yes?
So you've said that Hive is of the 13% of all your grid jobs, like the consumption. So what is the
Computing consumption, yeah.
computing consumption?
Yep.
So what is the execution engine behind Hive? So do you use MapReduce jobs? Are you using
Well, there's MapReduce. We've also moved on to Tez. And I'm trying to think now. That's not my field of expertise, but I see these names scroll through after a Hive job is done. And Yarn is also helping to speed things up a lot as well. But yeah, MapReduce was the big one. So Tez was just rolled out, I think, earlier this year. We're a very big company, so it takes a while for us. That's another reason why I like coming to universities, because you guys get to adopt things like at the drop of a hat. But we're a very big company, and there's a lot of impact if any one thing goes wrong. So it takes us a while, and a lot of QA has to happen before we ever roll out new stuff. So MapReduce was really the biggest thing for up until this year. Yeah, and still runs a lot on the Hive jobs. Yep. Thank you for that question. All right, so I want to now take you into some examples of what we do in marketing with big data, and then look beyond that into the rest of the company. Not projects that I'm involved with, but just things I think that might be of interest to you They're publicly available, and if you're interested in, you can do a deep dive and look up the source materials online. So big data in practice at Yahoo. Again, just to give you a sense as to the size of big data at Yahoo, this down here is a 2-year growth rate on each of these entities. We're right now at our HDFS, the file system. The Hadoop file system is about 592 petabytes. I always put this little cheat sheet here to remind me just how big a petabyte is. 1 quadrillion bytes, or 1,000 terabytes. This over here is the number of jobs, 1.2 million jobs per day. This again is across the entire company. This has grown 41% in just the last 2 years. Fortunately, we haven't had to grow our hardware as fast as we have grown the amount of data we're storing and the amount of processing we're doing. So the good news there is that we're getting more and more efficient at processing all of this large quantity of data. So we have about 36,000 nodes. Think of them as essentially computers, and that's grown just 13% over the last 2 years. All right, so how do we take advantage of this in marketing? And I'm basically just, like I said, there's not a lot that I can show you, but I can tell you sort of at a high level what we do. What I've learned when I came to marketing is that segmentation is everything. So marketers, the first thing they want to do is they want to segment their populations. They want to understand you as an individual if they can, but if they can't, they want to put you in a category of people, and that's how they understand the marketplace. So we use a lot of data to help us get smarter and smarter about how to effectively segment users so that our products can service our users as effectively as possible. Marketing effectiveness and reporting. So when we do marketing campaigns, we are collecting data on who sees them, who acts, and how people act after they've seen them. That helps us then to figure out whether the campaign was effective or not, and then we have to report all that data out, or those results out, to our executives. Email targeting. So if you have Yahoo email, you may occasionally see some call to action in your email box that has been generated by this big data system that says, hey, you're probably a person who might like to see this message and who would act on it and get value out of the service that we're marketing. User lifetime value is just a way of collecting data on how people have taken advantage of our products and services and figure out how much that's worth to the company. That helps to calibrate how much we're willing to spend to market products to you. Next best product is a very important data science technique, which is basically looking at the products that you've enjoyed in the past and guessing at what are the products you might enjoy in the future. So that might be tied to an email targeting campaign. So we say, hey, people who have consumed a certain amount of time on product A are very likely to also enjoy product B, and then we'll send out a message on an email, say, hey, check out what we're doing with product B. Sales support was sort of a former role where we would support sales efforts to sell our services to advertisers. Modeling user engagement with products and devices. So this connects up to user segmentation, where we are helping our product teams understand what are the components of their products that are most valuable in the marketplace. And then finally, network health. As I showed in a previous slide, I have one guy on my team who is using data to understand how it is over all of our products, how they are contributing to the greater good of the company in terms of an entire portfolio of products and services. So this is kind of marketing in a nutshell. Each one of these is supported by some extent with big data and or data science and algorithms. All right, so let me take a quick tour on the things that are happening outside of marketing. And again, as I stated, all of these are publicly available, so if you have a deeper technical interest, you can access them online. One of the easiest things to conceive of and that you can see basically with one of our products and how we use big data is search. And what this shows here is basically the layout of a typical search page, where here are the results where we have to rank these results according to what we think will match the query that you've typed in. In this case, it's 2015 Mercedes technology package. And then around the results are advertising. And these ads must match the query as effectively as possible. So behind all of this is a lot of data on the semantics of the query that was typed in. There's a lot of data on what's available out there on the web and how these two will match to make an effective presentation. One of the things that the engineers had to solve is that the massive amounts of information really was hard to process. We had data collected on one set of systems and we had the data science algorithms on another system. And they had to figure out how to get the machine learning and onto the same Hadoop cluster that the data was stored. Once they did that, this whole process worked a lot faster. Some of the techniques that they've used, gradient boosted decision tree, neural networks, and logistic regression are some of the tools that they've used on the machine learning side of things. So this is a very basic way in which we bring big data and data science to bear on one of our products. Any questions on that? Yes?
This is a very classic example of user actually ad targeting or matching ads.
Yep, exactly.
So, and it's obviously based on the query that the user has submitted. So, but how about the mobile advertising? For example, if I have Yahoo News or something on my cell phone, how do you match the ads with the user interest? Because there's no query or something.
Are you talking about the ads, for instance, that show up in the feed, what we call native advertising? Or are you still talking about mobile search? Yeah, so that's a different kind of algorithm. I mean, it's the same concept, but when you see ads, so if you're on a Yahoo product, say our news stream, actually you'll see this on Facebook as well now, but you'll see ads every now and then inserted in the middle of the stream. And that is based on, if you're logged in, it's based on your personal profile that you've created with Yahoo. So hopefully if you've given enough information in there, those ads are targeted to things that you're interested in. If not, then it'll be based on a larger corpus of information of just users in general. So we might show ads that are based on past clicking behavior on news articles that you've clicked, or it'll just be from a general bucket. So it just depends on how much you have told us about how you want to model your experience.
If somebody's not logged into Yahoo products,
Yeah.
so you get the data from only Yahoo products, so only my activity on Yahoo products, or is there any third party?
Oh, I see what you're saying. Yeah, it's based on Yahoo data. Yeah. Now, there are other scenarios. Well, I don't want to get too complex, but there are third-party providers that can help that targeting improve even more. For instance, if you're a user coming from another site, there are third-party data management platforms that they're called that will help negotiate how to best target a person that's come from another site or another network. But again, that gets pretty complicated in terms of the amount of data that's swimming around. Yeah. Yes?
One of our online students would like to ask you if you use any data warehouse for quick analytical queries, something like Redshift or HBase?
HBase, yes.
HBase?
Yes. Oh, sorry, I forgot we're streaming too. So hello to everybody online. Sorry, forgot to recognize them. Yes, we do use HBase. Redshift, I'm not familiar with. Yep. All right. So did I explain your question? Okay. So another example is our Yahoo Answers product. This is a pretty old and well-established product where it's basically user-generated content where people can go ask questions and get them answered by the general community. So the system that's used to score the quality of the responses is called Automatic Quality Scoring, or AQS. And we and others use it to improve user engagement on the site. So the problem that we have, though, is that it's another jargon term, community question answering sites, or CQA. The problem is that, the wisdom of the crowd is great on one hand because you can collect over a wide body of people and experience and get a good distribution of answers. But sometimes the way that satisfies a person's question is insufficient. And we wanted to know whether an AQS could improve not only the answers ranking, but also improve users' engagement on the website. So the solution was to use a syntactic I always have trouble with that word, syntactic and semantic and social signals to put that all together into an algorithm to improve our way of ranking and displaying those answers to you. So syntactic in terms of just the structure of the language that's used on the site, semantic in terms of the meaning of the words that people use, and the social signals are things like thumbs up, thumbs down, thumbs up, thumbs down basically on the responses. So here's, maybe kind of hard to see, but here's a typical answers page. There's a bunch of categories that you can look at on the left-hand side, or in that box up there, you can search answers for questions that you're interested in, or if you're logged in, you could actually post your own question and wait for people to respond. Here, you can see how many answers there are and how many people are following that question actively. And then over here is how you sort the answers. So relevance is, uses the automatic quality scoring system. Again, there was a lot of work that went behind this. I'm really summarizing this at a very high level, but this result here showed, and what the scientists, the contribution that they made is that basically, as far as they know, this was the first attempt to show that not only can you improve ranking, but you can actually improve engagement with the website. So over here is a graph of one of the ways in which they determined engagement. It's a thing called maximum scroll depth. So the assumption is that the deeper you scroll into a page, the more interested you are in that page. Now obviously there could be some outlier cases where you're scrolling because you don't find the answer you want and actually the experience is not good. But they determined in this particular case that that was well correlated to improved engagement. And as you can see at the bottom, at the x-axis, are the number of good answers, good determined by the automatic quality scoring system. And it tended, the more good answers that you had, the more people would scroll and read more. And so there were all sorts of other charts in this article to show how they demonstrated improved engagement, but this was a pretty powerful one. And one of the reasons why the lines, like this last line stops at 3 is because there were only 3 answers provided on the page. So the great thing about this system is that we can actually provide pretty good ranking even when there's very limited number of answers provided on the question. Any questions on this one? I want to make sure I'm not flying through these examples too fast. Yes?
So how do you decide that the answer is really good? Like it's just based on this automatic query?
Yeah, that algorithm basically used those 3 signals that I was talking about. So as an example, when people do the thumbs up, thumbs down, we can also look at the way that their previous thumbs up, thumbs down were consumed, or how much engagement there was on their answers in the previous questions that they've responded to. We also look at, they used actually I think it was about 40 or 50 what they called experts, human experts, to provide sort of the training set, right, of responses. So that, sorry, not the training set, but the baseline of what qualifies as good. And they used them as a way to compare the results of the algorithm to see how good they were matching up. So it was a pretty multifaceted approach. So they used humans to calibrate their answers, and they used the previous scoring of people to come up with the algorithm, the automatic scoring system that they came up with, yeah. Like I said, the paper has more details. It doesn't actually provide you with the specific equations or anything like that, but you can get an idea as to different kinds of quality signals that they used. Like for instance, unfortunately the paper didn't go into the very details of the text mining system that they used to deconstruct the semantic meanings of words, the syntactic structures of sentences. But I'm sure those of you who are into text mining can already think of several tools that can help you do that. Yeah. Yes?
Do you also identify like a certain domain expert, like from how people answer, his answer is more address this question, always in a very good high AQS score, and do you engage these kind of people to provide more incentive to provide answer to similar questions?
So there is a program where industry companies can sign up to answer questions. So just a very basic example, and I'm making this up, so it's not, I don't know whether we actually signed up HP, but say for instance, HP wants to sign up to answer questions on computing technology. They could pay a certain amount of money, and then they would be the domain expert. And you can imagine the power of that is that people will trust HP's answers maybe more than just a random person. Not necessarily, but hopefully. So yeah, that program has existed. I'm not sure whether it's currently still running. But you may, on answers, come up against, you'll see experts chime in on certain questions for sure. Yeah. All right. How are we doing on time? Good. Here's another example of how we use big data on Flickr, which is our photo sharing platform. This thing called Magic View basically creates tags automatically, or as some people would say automagically, creates tags for pictures to help better organization of the entire corpus of pictures in the database. Here, this is just an example here. So when you post up a picture, you'll have your own set of tags, and then we will add a certain number of automated tags based upon our own algorithm. And it is a image matching algorithm that takes advantage of the fact that we have 12 billion images across millions and millions of accounts. It runs on a neural network that runs on NVIDIA's GPUs. So NVIDIA was actually pretty happy to be able to promote this neural network that was running on their GPU system. We use Hadoop stack. The main technical challenge that they had to solve was making this a fast enough process so that it didn't bog down photo sharing. So what they had to do was create a system, a two-tiered system where there's a real-time system that creates tags, and then a database that's more static, that's storing the huge amount of current tags. And then at certain points in time, there's actually I'll just show the infrastructure diagram here. In the middle, there's this thing called a cleaner that will go back and say, okay, if any real-time tags have been created that already exist in the larger database, then they will be cleared out, and we'll just point to the ones in the database. But this is done in sort of a batch system so that it doesn't slow down. So every time we're creating tags, we're not going back to the main data warehouse and slowing down your ability to post tags, pictures on your account. We have a real-time system that handles all that, and then at some point later, we synchronize the tags that have been created for your pictures with the larger database. So that was the major technical challenge they had to solve. They used Pig on the algorithms that are working on the main database. Oozie helps on the real-time processing. Storm is the operating system that powers that pump. And like I said, the cleaner is what resynchronizes the real-time system with the more static data store for all those tags. All right, any questions on this one? Yes?
So what was the duration of that batch thing?
What was that again?
What was the duration of that thing?
The resolution?
The batch, the timing of the batch. So every hour, every 2 hours?
Oh, you know what? They didn't mention what the frequency is of that process. My impression was that it's very fast, but I didn't see any statistics on the timing. Yeah, sorry. Yes?
So you actually use image detection algorithm from this company, right?
Oh, no, this Magic View is not a company. It's just the name of the system that we're using to automatically tag.
And you more detect the object inside the image, the color, or do you also can detect some semantic meaning or semantic related things?
That's probably pushing it, the semantic meaning of it, but yeah, things recognize simple things like cat, dog, beach, sunset, car, building. Those kinds of things can be recognized for sure, yeah. Any other questions? Yes?
Do you also do some MRI, like a brain scan image? Do you
Oh, no, I don't think so. If there is, I haven't seen it. That would be pretty awesome. All right, so one last or two last components, a little bit more fun. Not Flickr. Flurry is a company we acquired, I believe, last year. They do analytics for mobile apps, so they allow app developers to track metrics on their applications. And one of the things the Flurry analytics team did was look at what can we learn about people's patterns on engagement with apps during a big event like the Super Bowl. The reason why we can do this is that Flurry is installed on across 630,000 apps, so it's a huge universe to look over. We collect about 7 billion sessions per day worldwide, so it's a really large amount of data for us to process and be pretty confident with these kinds of results. So what they did was, let's see if I can describe this very quickly. They indexed, so the Super Bowl is, if you don't know, happens on a Sunday. It's the big championship for the American National Football League, which is the American version of football. And what they did was, for I think that the last 3 or 4 Sundays before the Super Bowl, they indexed app activity to 100. And then they looked at sessions during the Super Bowl Sunday, and then they just kind of annotated where different commercials occurred and also where halftime occurred. So when there's a big drop, this is the theory, where there's a big drop below 100, that's a below average number of sessions for that given hour, or I think it's an hour, maybe it's 15 minutes of a Sunday. That means that people are paying a lot of attention to whatever's happening on the screen. When it jumps up, it means not only did people not pay attention as much, but maybe what they saw before, they're sitting there texting about it and sharing what they just saw with their friends. You see that big time at the halftime show. So Katy Perry was the highlight, pop singer Katy Perry was the highlight in the 2015 Super Bowl, and you can see app sessions plummeted during that time, and they started to come up as people start to text, tweet, share, whatever, about the things that they were seeing at halftime in their commentary. So you can use this to sort of index across to see which commercials had a lot of engagement, right? So it's a way of using mobile app activity to understand what people's television viewing behavior was probably like. They're big. The one quote that I pulled out of there, one of the big insights they had was that the jerky nature of our attention during the Super Bowl suggests that when we see something on the screen that grabs our attention, we immediately turn to our devices and apps to discuss what we just saw. So that's the concept. When it drops down, we're paying more attention to the screen. When it pops up, we're texting about it or sharing about it. Now, the 2016 Super Bowl was interesting in that it had 3 performers, Coldplay, Bruno Mars, and Beyonce. And what the interesting little note that they showed here was we could see which artist actually was most watched based upon this analysis of app sessions. So I pulled a chart base that shows an overlay. The blue line is 2016 Super Bowl, and the greenish line is the 2015 Super Bowl. One of the immediate things you can see is that app sessions have dramatically increased already in 1 year. But also what happened here in this halftime is that this was when Beyonce came on stage, and you could see how much more people were interested in her performance than Coldplay or Bruno Mars. And then you can see this tremendous spike right afterwards as people are chatting about what they just saw Beyonce do on screen. So it's another technique, again, of using big data, information on app sessions to understand what's essentially an offline activity. Any questions on that? Yes?
That's really fascinating. But what about people who are watching it through an app, streaming the Super Bowl through an app?
We couldn't cover that with this analysis, so that's essentially being assumed away. Because I think the only apps that you would be able to do that with would be like Verizon's Direct or something like that. And I can't offhand tell you whether or not they're using Flurry to measure their stats. But that's a good point, because that's going to be actually even more important as we go on. If you're a football fan, as you know, Thursday Night Football, you can now stream on Twitter. And so that would definitely complicate analyses like this. Oops. Yes?
Can you give us a couple of more examples of the kind of apps which uses Flurry? For example, are these texting apps or social media or what?
Yeah, I'm not sure whether I can give you a list of them.
Brief areas of like...
Yeah, so there's, as I said, we have 630,000 apps, so you can almost imagine almost everything of importance. So certainly gaming apps use Flurry to track user engagement metrics. So yeah, I mean, 630,000 apps covers a huge universe.
So the way it works works is that app sends information to Flurry and Flurry analyzes what's going on.
Yes, yeah. And then we analyze it and we provide insights for the app developer. And then in an anonymous aggregated sense, we can do analyses like this, where we don't mention anything about any particular app, but we can talk at a very high level, aggregated level. Yeah, yeah. All right, and I think there probably is a way you could tell on your app whether they're, in the user agreement, what kind of tracking that they have inside the app, if that's of interest to you. I think they have to disclose that in the user agreement. Yeah. All right. Any other questions? Yes.
I'm sorry. I assume Flurry is fairly inexpensive then to put.
Oh, it's so inexpensive it's free.
Yeah, because the obvious value is just collecting the data from everyone that you can get it on. Yeah. Okay.
Yeah.
Yeah. Thank you.
Yeah. All right. Wow, time flies. Because I do want to touch at least the last part about just big data as a practitioner, what things to think about as a practitioner, I'm going to skip through this, but just point to you that we've also, our lab scientists have also come up with this automatic video summarization. You see this actually on YouTube. If you post up a video, you'll see what they do on YouTube now is 3 different images to summarize what that video is about. This is a way of using big data to make video browsing much more efficient. But I'm going to skim right through that because I want to spend just a few minutes at least on this last topic. So basically what I just showed you was how marketing uses big data at scale. I showed you how massive the scale is of big data at Yahoo. I showed you how marketing takes advantage of big data and some of the way our product teams take advantage of big data to improve the user experience. So I just want to walk through a few things about things just to think about as a practitioner as you leave school, even if you become a professor. Things that big data hasn't changed. And one of them, these 2 quotes I like that supposedly came from Einstein. You always have to be careful about quotes because you're never 100% sure the person said them. But I like the quotes anyway. The difference between stupidity and genius is that genius has its limits. But then on the other hand, he says once we accept our limits, we go beyond them. So how do we how do we make sense of what looks like a contradictory statement? Well, on the one hand, what Einstein was saying here is that when you're a genius, when you're truly smart, you know the limits of your knowledge in terms of you know what you know and you know what you don't, you're aware of what you don't know. Stupidity is when you think you know everything, and we know you can't possibly know everything, you speak on everything, you have an opinion about everything, and you speak as if you're an expert on anything because you're talking about it. That's kind of the way I interpret what Einstein says. But the good news is that when you understand the limits of your knowledge, you can go beyond it because you know what is the next step of inquiry to help improve yourself, to learn more. And once you learn more, you're going beyond that previous limit. So that's kind of the way I kind of reconciled these two. And I think it's important as data scientists and practitioners of big data to understand this concept that we can collect all the data we want, we can have all the smart algorithms we want, but we still can't know everything, right? And that we are going to be most effective when we understand what it is our models cannot do and what they cannot speak to, right? So that we can help others understand what's the next step of inquiry. This is a lot of words, but this is something came from economist in 1945 named Friedrich Hayek. I'm just going to read it straight from the slide. Bad presenter etiquette, I know, but it's a lot of words, and then I'll kind of interpret it. So the peculiar character of the problem of a rational economic order is determined precisely by the fact that the knowledge of the circumstances of which we must make use never exists in concentrated or integrated form, but solely as the dispersed bits of incomplete and frequently contradictory knowledge which all the separate individuals possess. Unfortunately, back then sentences were very, very long and used lots of words. The economic problem of society is a problem of the utilization of knowledge which is not given to anyone in its totality. So in economics, Friedrich Hayek used this concept to say that, hey, no one person can know everything, but by using free markets, property rights, and prices, people use those techniques to come to understand things about products we couldn't otherwise know, or markets. So for instance, just by the fact that something costs more than another, you have information that no central entity or information system might otherwise know. And how do we get to those prices? It's by the interactions and the transactions amongst individuals. And the way I kind of apply this to big data is that we also face a problem of understanding where we could never collect enough data on the world to understand everything. But the currency of our learning and our development is the way in which we iterate through decision making. So if you think about the process I showed before, our quest for knowledge is like this iterative process where we're using all these transactions of experiments, basically experiments and observing what happens when we put our products out in the world. That's how we iteratively and incrementally get to learn more and more. And then finally, this is actually related. This is from business management. So you can see, a management science book. You can see the difference in sentence structure right away. We see people acting, but the constraints under which they are acting are largely invisible to us. This is very important in the world that I'm in the internet, in Yahoo, because we have data on user behavior and whatnot, but there's so many things that you are doing while you're on an app, while you're on the desktop, that we'll never ever know anything about. We don't know that there was a crying child in your lap at the time that you were reading some news article and it took you 20 minutes because you kept getting distracted, right? We just will never know that. When it comes to the flurry analysis, right? We may not know that you are actually in the kitchen cooking while that was going on, and what you're really texting about is all the great food you're about to prepare for all your buddies that are coming to watch the Super Bowl. We just don't know that. And it's important to know that in the internet world because we'll never collect enough data to understand all the things that are acting upon and driving behavior. They will always be invisible to us. This I'll just blow right past really quickly. This is a podcast that unfortunately I don't think they're going to run it again, but I highly recommend it for you as big data practitioners, called Raw Data. They talk about all the practical ways in which big data is impacting society, and I put some bubbles up here to show each of the different segments. Some of my favorite ones were Love, where they talk about how scientists are trying to use big data to help improve matchmaking. The digital afterlife, something I never thought about, is like what in the world happens to all the stuff you create after you pass away, and the different things different companies are doing to give you permission to pass it on to your heirs. Of course, they talked about new money, digital currencies like Bitcoin, and then the Hippocratic algorithm, which is another concept, which, doctors have the Hippocratic oath, which actually is not totally accurate, but that says do no harm. This is something that actually they were proposing that data scientists, because of the amount of power we can wield with the data we have, is something that we adopt. Some sort of creed or statement that says we will do no harm with the algorithms we create. And to that end, I'll just end up, there's a Slate Money podcast called The Weapons of Math Destruction Edition, September 10th. And Kathy O'Neill, PhD, I think in mathematics, she wrote a book called The Weapons of Math Destruction Edition, which talked about the different ways in which we can use big data to be destructive, right? And there were 3 things she came up with. I'm going to fly through them. Is questions to ask about whether what you're doing is either helping, or is it being destructive? So one of the things is a widespread objective function. Some examples are algorithms that control people's work schedule, for instance, right? A lot of companies are now being very smart about how they schedule their workers so that they have very specific times at which the workers come so that the workers be as efficient as possible. But the impact on people's lives can be very tremendous. If I want 4 hours of work on a given day and the company only gives me 2.5, that will be suboptimal to me, and it also may be more disruptive to my organizing around daycare and so forth. The company calls me in the morning, says we need you to come in the afternoon. Some of the questions to ask is whether your algorithm is self-correcting and what are the incentives, right? Does the algorithm correct against bad outcomes? And what incentives does it give the people who use the algorithms or are impacted by the algorithm? Mysterious scoring. Does the algorithm have mysterious scoring? So, for instance, in lending and credit, a lot of credit decisions are made by these algorithms. Question to ask is, who has accountability for the outcomes of those algorithms? Is there due process? Can someone, does someone have an ability to question the outcome of that scoring for whether or not I get credit or a loan? And then finally, does the algorithm have destructive impact? So that's a little bit more obvious. Does the algorithm cause people to lose their jobs? Does it cause them to stay in jail longer? The example she gave was sentencing algorithms which basically say that if you return to jail if you showed a certain amount of criminal behavior in the past, but that automatically means that you should be in jail longer going forward. That has a very, that loop basically traps people into jail for longer periods of time. So some of the questions to ask is, does the algorithm have destructive feedback loops? Are there trapping states? Is it, if someone continues to do certain behavior, are they eventually going to end up in that state and not get out of it? Some of you have heard of the social networking bubble, right? The more you like something, the more we give you the thing you like, and so you never see anything else and you're never exposed to anything else. That's a controversial topic right now in the industry. Does the algorithm punish or help? So you can use an algorithm, I'll go back to jail populations again, to further punish people, keep them in jail longer, or you can use it to identify people who need help, like mental health assistance, for instance, right? So you can decide whether your algorithm is going to punish people or help them improve themselves, and what kind of opportunities are withheld from them. So with that, I will conclude. Thank you for your attention. If there are any questions, additional questions, I guess I can answer them after the segment. All right, thank you very much, everyone.